Welcome to your first official lesson and your first official calculus chapter. All of last chapter was just review. This chapter we're actually doing some calculus topics. This whole first chapter is about limits. Now, informally, a limit is a y value as a function approaches some x value. So as we get closer and closer to some x value, what's the y value we're getting closer and closer to? So if I look at this first one, this is as x gets closer and closer to -4. And that means from both directions. So I'm going to look. As this graph gets closer and closer to -4, when x is -4, what is the y value that we're getting closer and closer to? Well, it looks like we're getting closer and closer to y value of 1. Now note, this is different than this. F of -4 means what is the y value when x equals -4. That's different than over here where x is approaching -4. That's different than when an x equals -4. So if we look where x equals -4, that function value is 1. They're the same. That's not always true though. In this next one, let's look at this. As x approaches -1. So here's where x is -1. We're looking where the graph is approaching x equals -1. As it's approaching x equals -1, our y value is approaching 4. But if I look at this one, where x equals -1, when the graph equals -1, there's a hole. So it's not going to be 4. That hole is filled right here. So if I were to plug -1 into this function, it would give me a y value of +1. So that shows you the difference between as you approach an x value through a limit versus when you just plug an x value in. Let's look at another example. As x gets closer and closer to 2. So this one, as I'm getting closer and closer to 2, that y value is approaching 1. But if I want to do where x equals 2, so I'm going to look right at 2, well, that's a hole. So the function doesn't exist. Does not exist. It doesn't exist at 2, but it does exist approaching 2. Let's try this one. As x gets closer and closer to 3. So as I am getting closer and closer to 3, looks like my function is going down to -infinity. Or does not exist. For AP Calculus, if you have infinity limits, if you put does not exist, the grader will grade it as correct, because technically infinity isn't a limit. So you can put either of those and that would be correct. Now if I want to put f of 3, so that's where x is 3, well, where x is 3, that function doesn't exist. Doesn't exist at 3. Okay, last one. As x gets closer and closer to 5. Now, like I said before, this is from both directions. So if I look as we get closer and closer to 5 from the left, that looks like this point at -1. But as I get closer and closer to 5 from the right, that's up here at 2. And we can see that right here in 6 and 7. So this, as x gets closer to 5 from the left. So if I go to 5 from the left, That's getting closer and closer to -1. But if I look at as x gets closer and closer to 5 from the right, that little positive symbol, that's getting closer and closer to 2. Now this one is called the left-sided limit. This one is called the right-sided limit, coming at it from the left and from the right. If the left-hand side limit does not equal the right-hand side limit, then the limit from both sides does not exist, because it's not the same from both sides. Now once again, I look when x equals 5. So if I go right at 5, right here, that one's going to be 2, wherever the closed hole is. So that is a little introduction to limits. In the next video, we'll talk about some continuity and how that relates to limits.